How do W/MK describe thermal conductivity? Have you ever wondered how heat travels through different materials? Understanding thermal conductivity can help us grasp this fascinating process. Let's break it down in simple terms. Thermal conductivity is measured in watts per meter Kelvin. This unit tells us how well a material conducts heat. When we say watts per meter Kelvin, we are looking at three key components. First, the W stands for watts, which is the amount of heat energy transferred every second. Next, the M represents meters, indicating the thickness of the material that the heat is passing through. Finally, the K stands for Kelvin, which shows the temperature difference between the two sides of the material. For example, if a material has a thermal conductivity value of 1 watt per meter Kelvin, it means that 1 watt of heat will flow through a 1 meter thick piece of that material when there is a 1 Kelvin temperature difference across it. Now, what does this mean for different materials? A high thermal conductivity value indicates that a material can transfer heat quickly. Metals, for instance, have high values and are often used in applications where efficient heat transfer is essential, like heat sinks in electronics. On the other hand, materials with low thermal conductivity values, such as foam or fiberglass, resist heat flow and are commonly used for insulation. This helps keep heat in or out of buildings and appliances. The thermal conductivity of a material is not fixed. It can change based on temperature, structure, and impurities within the material. For instance, as the temperature increases, some materials may conduct heat better or worse. In practical terms, knowing the thermal conductivity of materials helps engineers and designers make informed choices. They can select the right materials for specific applications, ensuring safety and efficiency. So, when you see the unit watts per meter Kelvin, remember it is a way to measure how well heat moves through materials. Understanding this concept can help us appreciate the science behind heat transfer and energy management in our everyday lives.